Okay, good morning, everyone. Welcome to day two of our 3D CAD and printing session. Today we'll be talking about advanced modeling and house assembly. Last time we talked about the basics of CAD and what 3D printing entails. Today, you'll by the end of today, you'll understand how uh, real objects real objects are built and how they come together. You'll understand how the structures, multiple parts, separate parts, are combined to make a single object. Think of a instead of a solid shape, think of a Lego, but engineering. So last time we did a single object like a phone stand or a key holder. If you check our previous lesson on YouTube, but today we're going to be talking about a modular design. It's just going to be a simple structure, nothing too complicated. So, like for example, real life, we have walls, we have the base, we have the roofs, we have the house, the doors, we have the windows as well. Uh, So we're going to be making all of that and combining each and every one of those single parts into one main uh, building or assembly. But here's the thing I want you to understand is that engineers don't always use um, screws or glues or adhesive. There's something we call a modular design. What we mean is using clips, snap fit, that slots that goes into holes or um, like for example like this. If you check our template right here, what I mean is like a tab that pushes into a hole and clicks in place. So there's going to be no need for screws or glue to keep the parts together. So we don't always use when we're in the testing phase. We don't always use screws most of the time because it might be a waste of material. If you can get the dimensions correctly, you can make a hole that goes into a slot without having to spend extra money on material. So why do we use a modular design? It's pretty simple. So for example, we have a it's easy to separate, creating objects using separated pieces that connects together. Each part has its own position. It's flexible, easier to build, and it's easier to repair separate parts as well as the assembly. So today we're going to be looking at using a more advanced software than we used in the previous lesson. Last time we used the Tinkercad, but today we're going to be using a mechanical engineering software called Autodesk Inventor. With this software, it lets you not only model, but it lets you calculate the cost of material, lets you calculate the weight of the material. It's really a precision, like I say right here. It's really a precision modeling software for real life manufacturing. It's what I use mainly for my day-to-day job. So most of the materials we make in the production floor, I have to first of all design them on my computer and make sure that the parts fit correctly before it's produced. And that's how most buildings are made. So today we're going to be making a simple, basic assembly of a house using tabs and slots. So we're not going to be using any screws to uh, have this click in place. I'm going to show you how we can use tabs and slots to ensure that each of these separate parts are combined together effectively with correct dimensions. So first of all, we're going to make the base of the house, then we're going to make the walls as well. Those are going to be separate parts. This is the plan. It's going to be it's something basic. So at the end of the day, I'm going to convert this into a 3D version, and you see it's very, it might look a bit confusing or scary, but it's really not. It's really basic, honestly, and I'll show you how easy it is. So we're going to quickly move into Inventor so I can show you what the software is all about. Okay, so when you first open the software, this is what you're gonna see. And I want to first of all make a new part. So if you remember, this is what we're gonna be making. So I already have this opened somewhere else. So I'm just gonna be calling out the numbers. It's gonna be easier for us to understand that way. Okay, so the first thing that I want to do, I already told you guys how to move in a 3D space in our previous lesson. So I'm not going to do much in explaining this software because it's very, very broad. But as we go through each step, I will try my best to explain each of the tools that I use. But the software is most often self-explanatory because when you select a tab or a tool, it tells you what it does in simple terms. So this is the extrude. This is going to be a very important tool that we're going to be using today. So first of all, we're going to begin by creating a 2D sketch. If you remember the plan view of the building that we made. So first things first, I need to change the unit from inches to millimeters because we're going to scale this down. So now I select the rectangle tool. This creates a rectangle or a square. So the first thing I'm going to do is make this 100 by 80 for the width, and then the length is going to be about 150 millimeters. So our unit is going to be in mm, just for you to take note. So we have to make sure that everything is accurate. So as you can see, we have our first box. Now the next tool that we're going to use is offset. So now what the offset tool does, it duplicates the sketch that you've made. So when I select the offset tool and I select this, I want to make the thickness of the wall. So that's how thick the wall is going to be. So let's say something like 4 mm should be fine. Yes, we don't want to make it too thick since it's just a scale model of the building that we're going to be making. So I want to rotate this a little bit. Yes. So using the view cube, you can change the view, rotate it left, right, zooming in. I already explained most of the controls with Tinkercad, so it's similar. So you don't have to. Most of the CAD softwares are similar in control, so you don't have to overcomplicate yourself or relearn the software when you're trying out a new one. So the next thing that we're gonna make is a bedroom. I'm gonna make it something like let's do 60 by 70 mm, and then we're gonna offset this again and make the wall thickness 4, so it falls perfectly in line. And then we're gonna let's make the bathroom next. Let's see, uh, let's do 40 by 40 mm. If you remember in the last class, I told you that you have to make sure that all your dimensions are accurate. You cannot you cannot do this halfway or do it You must make sure that everything is complete and precise, or otherwise your print is going to fail. So I want to extrude this outward 4 mm, because if we take it inside, it's going to be too big. And what we can do is delete these extra lines that we don't use. So I don't want to delete, when I select this, I don't want to delete this line as well. I only want to delete from here to here. So the tool I use is something called split. So it splits the line here and here as well. So I can just select only this and it's gone. I'll do the same thing for this, and I can select this and delete it. So there we have our bathroom right there. And now next we're gonna make a kitchen. So we can do something like let's try 110 by 40, 110 mm by 40. It should be good. There's no precise way in making this, so you can make it any dimension when you're designing. I'm just following uh, the drafting design we had earlier I showed you, where you can make yours as large or as small as you want. So that's so okay. So we have our living room right here, and then we're gonna have our bedroom here, the bathroom, and then the kitchen. So now we want to make the space for the windows and the doors. So for the kitchen, we can have a little window here and make this about uh, 20 mm for the window right there. We can add a door right here and make this 20 mm by 4 as well. We can add another door right here to get in the bathroom and make this let's say make the door smaller, 12, let's say 12 by 4. Sorry, this is wrong. So if you make a mistake like this, all you have to do is click the undo right here. Very easy, and that goes away. And next I can click this and make this 4 by 12. Perfect. So now that's going to be the size of the of our door right there. Next we're going to make a little window right here for ventilation. We're going to make this maybe make this 4 mm by 10. So remember, all of this is scaled down. What I mean, I'm using a scale of 1 to 50. What I mean is, if you want to get the real life scale of this door or this plan, all you have to do is multiply each of this number by 50. That's how you get the real scale. So it's actually very easy. So if we make all the parts the same, that's how we know all the parts are going to fit no matter what. So we can make this 20 25 by 4. That's gonna be another little window right there. And then we're gonna make a little door right here to get in the bedroom. Just make this 15, yeah, 4 mm by 15. Apologies, made a little mistake right there. The door's too small. So this should be 4, and this should be 15. Perfect. So that's gonna be our little door right there. So we're gonna make a final window right here for the ventilation in the living room, and we'll make this 30 30 by 4. Yes. All right, there we have our plan view. So we have a door, a window, a door, another window, a door, and two more windows. So now comes the fun part. So when you're done with this, you go into 3D model. So we want to turn this into a 3D model that we can actually print. So all I need to do is click on extrude. What extrude does, it creates a feature or a body by adding depth to the profile. So it creates an actual physical part. So when I click on this, we want to make this 50. Okay, I'll keep it as it is first to begin with. We'll select this as well. I'm gonna select all of the inner walls. Select this as well. This, and this. And now we're gonna give it a depth of 50 mm. So that's gonna be the height of our wall. So the wall of our house is gonna be 50. So now the next thing I want to do is make this previous sketch visible, so I know where each of the dimensions are, so I can make the walls and the windows and the doors and all of that. So the first thing I'm going to do next is create a sketch at the top of the building right here, and then for the window I want to project this geometry, project all of these lines. I'll tell you why I'm doing all of that. Then next is the windows. I think we've done this and this. So that's perfect. Now we're gonna create this door first right here. So I'm gonna click on the sketch, and then when I hit on this, it takes me to the wall. I want to project these lines. And from there, I'm gonna put a point here. This is where my door frame, the hole is going to start from, where it's going to insert into. So we're going to make it 30 by 25. Let me take this down a little bit. $20 mm by 35 mm. So this is going to be the slot for our door. We can take this down a little bit and make this 40. Yes, that's much better. And then we're going to extrude. You know, when we clicked on the extrude the last time, we were adding material, but there's another function to this. It can also take off material. So when I click on this box here, it comes out, but that's not what we want. I want to take off this material. So I'll click on this, and this is what we call cut. So it cuts the material, and then that's where our door is going to go right there. So we're going to make this little window next. and then we'll click on sketch, just like we did before. Project this geometry, and this is going to be a window of 10 by 10, because we have made it 10 mm. So I'm going to say 10 by 10, and there we have the window right there. We don't have anything else on this. I believe I should be able to select this next. I'll project this geometry to create this door. Then we'll click on extrude and cut like we did before. But this time we don't want it to go across this wall. So we're just gonna make it cover the entire thickness of this wall, which was 4. And there we have it right there. Easy solution. So next we're gonna make this door right here. So all we have to do is click on sketch again. And then like before, I want to project this 2 lines. Okay, someone asked me a question on YouTube, says, what happens if one wall is slightly too big or too small? That's why it's called it's a testing phase. If it's too big or too small, you will notice it while you're in the modeling phase, so you will be able to correct it. So all you have to do is find the dimension that's correct, talk to the engineer or whoever designed the plan, to that if you're working on a real world plan, or if you're using a AI, you can have it correct the dimensions for you. So it's not really a problem. That's why we have the design phase. The design phase is to check for any errors in the building phase, in the building project. So if there's any problem or any errors, you're going to notice it while you're in this design phase. So now we're going to make the door next, and we're going to make it a 12 by 30. We want it to go all the way down. We can make it let's make this 40 instead. Yes, that's much better. Next, we're going to extrude this door just like before and cut out the space 4 mm. So that's where our door is going to slide into. So next we're going to make this door next. Then all I have to do is project this, and add a point. This point helps me find the location, or the starting location, where I want to place my object. So I can make this 15 by 40 mm. There we have our door right there. And then you click on the extrude one more time and have this cut out 4 mm, and that's gone. Then we have one more window right here. Okay, we have 2 more windows right here. And like before, I'm going to project all of this and have this right here. Next, make this 20 by 30. Should be correct. This is going to be our first one. And then we can cut this with extrude one more time. we could have done both of them at the same time. So since they're both windows is on the same face of the wall, we can extrude both of them at the same time, or cut both of them at the same time. So I can make this 20 by 25, and there we have it. And then all I have to do is click on extrude one more time. Okay, so we have our windows, doors for ventilation, and all of that. So next, I want to add the slots. If you remember, we talked about adding slots that lets without screws. So we don't have any screws to use. So I'm going to make a slot and a hole where each part fits perfectly into the other. So if we go back into Inventor, I'll create a sketch right here. Now what we want to do is make a little hole right here. First of all, we'll make it a radius of 2.3 mm, and then we'll center it. So we know the thickness of this wall is 4, so we'll make this, probably this should be 2, and then we want it to be centered in the center of this building. So the easiest way, we know this is 180, so I can click this 180 divided by 2, puts our hole right in the middle, and then we'll create another one right here. We only need 3 holes to ensure the structural support of this building. And in order to ensure that this building does not fail, we need at least 3 holes. That's what I mean. That's what I mean by structural support. So when you're usually done with simulations, when you're done building the metal frames and the metal panels that hold the buildings together, you can run a simulation that tests the actual weight of the building, and it lets you know if there's going to be any problem in the later phase of construction. That's basically what this is. So we'll add another one right here for 2.3. I'm going to put this. What I'm doing is just ensuring structural support. So I'm just placing all of the holes in the middle, ensuring that it's smacked in the middle. So we have 1, 2, 3. I could place another one over here, but we don't want to waste our print material if we don't have to, because it costs money to get the print material. So if we don't necessarily have to add another one, there's no need. So the next thing we're going to do is extrude. So I'm going to select this. 1, 2, 3. So now if I was going to make the holes on the roof of the building, I would leave this way. So the building is going to slot into the roof, but I want the roof to slot into the building. So instead of making the slots, I'm going to make holes instead. So the roof is going to be the part that has the slot, and it's going to go in just like that. And we have it right there. Same right there. I made it 2 mm deep, so we don't want it to go in too deep. So now we're going to do the same thing for the bottom, the base. So what I want to do is create sketch again, then project this geometry. Since we already made the holes in the previous one, we don't need to make it again. All I have to do is project the geometry, and if I go back here, we're going to see the holes in the exact position where we want them. That's why it's a very powerful tool actually. So what all I have to do now is create another hole like we did earlier. So the base of the building that we're going to make is going to be the one that has these slots. And there we have it. We have the complete building done. From this we have this. All dimensions are accurate and perfect. So when we print this, it's actually going to print correctly because the dimensions are correct. So the next thing that we want to do, I'm going to save this as wall. So the next thing we want to do is create our base. I'm going to click a new part, and then start a sketch again. So we know that our building is 180 mm, if you remember from the first lecture. So 180 right here. So I'm going to make the base also have this length, or I can extend it a little bit. So it's going to look something like this. So I can say, oh, first I need to change the unit from inches to millimeters. So now I can go back to sketch, and then I'll make this 180 tab. So now how thick do we want our foundation to be? How this is going to be the foundation of the building. That's how deep it's going to be. So we know how wide it's going to be. So let's say it's going to be 10 mm deep. So if you want to get the true dimension of this, all you have to do is multiply 10 by 50, and that's how you know the base of your building. So then I need to extrude this. So if you check our previous plan, we know that the full length is 150. So we're going to make it this. So when I do this, then extrude it 150. But I can make it 160 if I want to add steps at any of the doors, or maybe a front door or something. So that's what we're going to do. And then I'm going to change the material of this to concrete. And there we have our base. So that's going to be the base of our building. So next we're going to make the roof. I'm going to click a new part again, create. So like before I showed you, it was a 180 mm. So all I have to do is sketch, create a line of that length, changing the units first. Don't mind me, I have to work, my work is all done in inches, but when I'm doing a CAD design for 3D printing, I usually run on mm, that's millimeters. So when I work, mostly in Canada, we use inches and feet. Yeah, but in Nigeria, where I come from, it's mostly millimeters, centimeters, and meters, and all of that. So it's still hard getting used to the changes. So I want to make a sketch first of all. Now I'm going to make it 180 mm. So this is going to be our roof. I'm just going to extend the line anywhere, and then create another line here and extend it anywhere as well. Then I'm going to use the dimension to give the angle of this building as 25. So the base that our roof, the roof of the building is going to sit on is going to be 25. Or I can make it 20 instead if I don't want it to be too big. The bigger it is, the more material that we're going to have to use. So if this is 180, when I extrude it, we're going to extrude it as 150. Perfect. So now the next thing that we need to do is save this as roof. So now we have all the parts that we need. I already created the doors and windows yesterday, so we don't need to go through making all of each of the doors. So for now, I'm going to show you combining the roofs and the windows. So it might be hard looking at this, so I might have to change the view for that later. So now we're going to combine all of it together. So this is what I'm talking about when I say combining them. So we'll create a new file called assembly. So in assembly, what we do is pick the parts that we already made. So first I'm going to pick the walls that we made right here, and then place it we want to flip the view of this. So right now it's upside down, so I'm going to rotate it. Okay, now there we go. So it places it right there. Next I will take the base. So this is going to be the foundation, and then I'm going to place it right here, and then I'll place the roof as well. Remember, this is just a model. So now we're going to combine all of these and then see how it works. The tool that we're going to be using is called constraint. So now I'm going to grab this and this. Wrong one. So we're going to make this flush with this. Ensure that it's the same. Perfect. We do the same for this. It moves it. So if we look at the top view, you can see that's perfectly aligned, just the way we want. So I wanted the door over here, so there's going to be a little step or more extra base right there. So now we're going to do the same thing for the roof right here. And then I'm going to pick this, place it, constrain this right here. And just like that, you can see each of the items is placed perfectly in the position that we want. So now all we have to do now is make these holes. So I want to make the slots where these is going to connect into this. So I'm going to close all of this. So it's easier to edit this while you're inside the assembly. So now all I have to do is create a sketch. And then just like before, since we already have the position of the holes, all I have to do is project geometry and right there. So now we know it's going to be in the exact position where we want it to be. So if I extrude this 2 and 3, so we're going to make this 2 mm. So this slot, you can see it right here, it's going to go above. So when I go back, you can see this is going to go into this. So when I add the constraint, all I need to do is click on apply, and then we have our base right there, and we know that it's going to go in. So we're going to do the same thing for the roof and project these holes onto this part. So all we have to do next is create a sketch like so, and then project these geometries right here. Project these circles as well as these as well. And if we look right here, you can see. So next, all we have to do is extrude. Do the same for this, and we'll do the same. Oh, look, this. So this is the error that I'm talking about. So if I wasn't in the model, I would not notice this. It's not aligned straight with the part. So I need to fix this. So I can click on finish and return. I'll go back to constraint. Now I want to add this right here. Okay. Perfect. So now we're going to make the sketch again. I want to project this to the top of the roof of the building. So then when I click on this, we have the same thing, and we're going to extrude it to the bottom, and then extrude. We have the first one, the second one, and the third one should be right here. And we're going to make it, say it's too long, it should not go all the way down. We're going to make this 2, and there we have it, our finalized assembly. So now what I have to do is go back, and you can see the assembly. I can bring in each of the doors to add in, like the walls. We can just start with the windows. You can fit it into the window over there. We already know the dimension of that window. So each of these parts are going to be printed separately, but I just want you to understand this window is not going to fit the size of this. So to fix that, the easy solution is I can click on the part itself, and I know that this should be 10 mm by 10, and when I go back, easy fix. So I made most of this in the previous lesson to fix, so we don't have to do all of these again. But if we make the window the exact size of this hole, it's not going to fit in. There's something that we call clearance. So we need to make this window smaller a bit, maybe by 1 millimeter, a bit smaller than this hole, so that it can fit in perfectly. So all I do is, instead of 10, I can make this 9.5 by 9.5. So that fixes our problem. So all I have to do now is constrain this to this wall, and then constrain this to this wall, and there we have our first window placed. So if I wanted to do the same thing for the door over here, all I have to do is get the door that I already made. So this is it right here. It might be too big for this. I know this should be 20. This should be, I can use the measuring, if I'm not sure, I can use the measuring tool If you go into the tools and go into measure, I can measure the size of the door if I'm not sure. Apologies. I need to make sure this is always in mm. So I can measure this. So this is 25 and this is 40. So all I have to do is select this part and make this 25 and make this 40. And when I go back, our door has been reduced. So all we have to do now is constrain it to that part and ensure that it fits properly. Okay, if you remember before I said we cannot make it the exact cutout of the hole, so we need to make it a bit less. So let's say 24.5 by 39.5, and there we have it. Simple. And I can just bring this over here. There are a lot of YouTube. This might seem complicated, but there are a lot of YouTube for those that are interested in learning Inventor. There are a lot of YouTube videos showing tutorials for the use of this, and it's very easy to follow. But if you followed our previous lesson, I would advise that you use Tinkercad, which is the beginner-friendly software. This is a more advanced software, and I would not advise beginners to learn on this. Okay, so there we have our door. So now we have most of, and then we can add the next windows as well. So all I have to do is place this. I would like to change the color of this window. So when I change the color or material of any part, it doesn't affect how it's going to print. The only reason Inventor lets me do this is because it allows us to calculate the price of the material. So we can have a PVC material and it's going to tell us how much it costs for each gram, because we have the dimensions correct exactly. It's going to tell us the weight. It's going to tell us every information that we could possibly need. So this is going to be a window. If I remember correctly, this should be 30 by 20. So I can place another window right here. Tomorrow's class is just going to focus on the economics side of this, talking about how you can turn this into a business or make money from this, provide services, and be functional in the society at large. It's because it's a very useful skill. So this is going to be 34.5, and this is going to be 20, and that changes the size of our window. So I can just make sure that this goes where it's supposed to and that it fits properly. Okay, so I can copy this and just do the same thing, paste it. So if I right click, you can see the copy right here. It lets me copy and I can paste it right here as well. So I believe this window should be shorter. If we check just to confirm, yes, this says 25, so I can change this to 24.5 instead, and that fixes the dimension problem. Okay, so how do you make both sides of the roof symmetrical? Questions on YouTube. How do you connect the house parts together? So like I have been using the constraint tool. It's a tool that lets you assemble the building parts together. And if you check the roof dimension, I make sure that each one if this was 25, if the left was 25, I made sure the right was also 25. So that's how you get it to be symmetrical, ensuring that the dimensions are the same, basically. So I can constrain this over there and constrain over here and apply, and we have that. This is confusing. Apologies, I'll be changing this one more time. Let's make it a gray colored roof. Yes. Okay, this turned out to be too short. Can make this 25 instead. Okay, so we have the windows, the doors, and each and every one of these parts. So the next thing that we're going to do is convert this into a part that can be sent into the 3D printer, which I will show you. I already have one which was currently printing, but I should be able to. I will save this and convert it into an STL file now. We'll save this. We'll save this. Call this 3D building project, and then we'll save. Okay, so when we send this, we're not going to print this as as a single building, because we want to print each one as an individual part. And when I say print each one, it means that I'm going to print the wall first, then I'll print all the doors, then I'll make all the windows, then make the roof next. I will be going over to Bamboo Lab Studios to show you exactly what I mean. So this is what I currently have. So when we send it into the printer, this is what you're going to see. So this is my actual printer right here. This is the printer base right here. As you can see, I have I already designed most of the doors. So I'm going to print all of the doors separately. And then these ones are furnitures like cabinets and shelves that are going to go into various areas of the building. I have the roof in another file. Most of these are the windows and the doors. So if I switch to our printer can, you should be able to see what I'm talking about. Yeah, so this is currently the live printing of the building I just showed you. I'll take off my face so you can see this properly. So as you can see, it's going to print from the bottom layer first accurately, and then it's going to move upwards. So it's layer by layer from the bottom to the top, basically. So that's what we mean by layer by layer. If I go back into Bamboo Labs and I show you the preview, it also tells you how long it's going to take depending on the scale. So when I say layer by layer, if I show you this view and I do this, you should be able to see what I mean. So it's going to start from the bottom and go all, okay, this should be a better view. So it's going to start from the bottom basically and go all the way to the top, making each layer, it's going to go around each one just like this. So it's going to draw each one. You can see it moving. It's going to draw each layer, ensuring accuracy. So that's why you have to make sure that all of your dimensions are correct, because it's only through your dimensions that you're going to get this accurate print. So if I go back to printer CAM, you should be able to observe it properly. So what it's using right now, it's plastic. So it's a different kind of plastic, a gray plastic, PLA, which I'm currently using. I showed in the previous class, I showed most of the PLA designs that we were using. I also showed the prices, as well as depending on the size and the type. That's that's going to determine how much you're going to use. So each for the wall, I'm using a very basic one because it's cheaper. So that's why it's going to be used for the wall. If I was going to design something more pricey, or something a little bit unique, I'll use a different PLA. You can tell you can tell the difference. You can see even from the camera that one shines brightly than the other. Why one is smaller than the other. This one is going to be more expensive than this because of the kind of material. So even in construction, in building, we have to take note of material. So that's what we're going to mostly talk about tomorrow when we talk about the economics. We're going to be talking about how you can turn this into a business and provide services for other people. So you're going to take account into how much the material costs. You're going to take account into the time it's going to take to make the material. So for example, making a phone stand. I believe in the previous class I showed you something similar like this, printed on the 3D machine, and can be sold depending on the amount of material used. So the machine tells you, if I go back into the software, it tells you how much you're using, how much material you're using, the grams you're using. It tells you the time it's going to take. It tells you how long each layer is going to take to print as well. So with all of these information, it's easy for you to calculate how much you want to set a price for your services, or how much you want to how much you want to determine a price should be worth. So depending on your time and depending on the material that you use. So that's what we're going to mostly talk about tomorrow. So I will show you various various graphs that explains most of these in simpler terms. And that's what most of our class for tomorrow is going to be. So in assembly mistakes, like I talked about tolerance issues, you need to make sure that the hole is not the same size as the cutout for the wall. Just like we are saying, we don't want to make the door the same size as the hole where it's going to fit into. We need to make it a bit smaller. That's what we call tolerance. It's the same thing for misalignments. So you need to, like the question that was asked on YouTube, how do you ensure that both sides are symmetrical? So you have to ensure that all dimensions are correct. That's how you avoid most of these mistakes. Same with fitment problems. It's the same with tolerance issues. You just have to make sure that if you're making a hole of 2 mm, you have to make sure the slot is a bit smaller than that. And in a real world engineering, most of the buildings that you've seen, uh, they first start off, like the construction of the roads or the bridges that I see while I go to work. You see them making the bridges first of all in the factory before they move it with a vehicle, and then they install it on site in the factory. So the bridge is not built on site; it's built somewhere else, and then so it's designed, built, and somewhere else, and then shipped to the site where it's going to be installed. So that's what modular design is. So we're going to design each wall. So usually, if I go back into the printer cam for Bamboo Studio, there's something I need to get across. If we were going to make this in a real world, we would make each of these walls a separate section, a separate part. We're not going to make it a single one. So this wall is going to be a separate one that was designed and made, and then we'll make this separate one as well. We'll make this separately as well. We'll make this separately as well. And then you can ship each and every one, each and every wall to the site where it's going to be held together by screws and heavy metals and heavy bolts. So that's using Inventor. That's how you test if this is going to work correctly. Using Inventor, that's how you test if this is going to work correctly. And you have to ensure that all of your dimensions are correct, like I said before. So for day three, like I said, we're going to be talking about uh, real world printing application as well as production. Like I said, we're going to be focusing on the economics tomorrow, same time at 11 a.m. I thank everyone for being here today and making the time to attend this session. I really do appreciate it. And even if you're not going to use this skill professionally, you can use it as a hobby to make money on the side or to help anyone that needs assistance with this kind of thing, because I've gotten a lot of freelance jobs for designing as well as modeling from various people, from businesses or university professors or whatever. So it's something that can keep you engaged. And tomorrow we'll look at the economics side. So I want to thank everyone for coming, and we'll see you same time tomorrow at 11 a.m. Have a wonderful day. Thank you.